If you're ready to do math today and you have your coffee ready, join me in the simultaneous sip.
The question we're working on today is diagonalize the following matrix. And the matrix is A equals 4, 2, 0, 0, 5, 0, negative 2, 4, 5.
Smash that like button and let's get started.
To start this question, we have to find the eigenvalues of A, and then we're going to find the dimension of their eigenspaces and bases for their eigenspaces. If their dimensions add up to be 3, then we know that we can diagonalize A, or A is diagonalizable. So to find the eigenvalues, we look at the matrix A minus lambda I, and find its determinant and set it equal to 0. We'll use the cofactor expansion along the third row, and we'll see that the determinant of A minus lambda I is 5 minus lambda squared times 4 minus lambda. We'll set that equal to 0, and we have eigenvalues 5 and 4. So let's find a basis for the eigenspace corresponding to lambda equals 4. That's the same thing as finding the null space of A minus lambda I. So we'll row reduce A minus 4i into reduced row echelon form. And we'll read off the equations corresponding to each of the rows. And then we'll factor out the free variables, and the vectors that are remaining is the basis for the eigenspace corresponding to lambda equals 4. And so now we'll do the same thing with lambda equals 5. If the dimension of this eigenspace is 1, then A is not diagonalizable. But if it's 2, then there would be 3 total vectors, and A is diagonalizable. So we find a basis for the eigenspace by, again, reducing to reduced row echelon form. And we see we have 2 free variables, so the dimension will be 2. So A is diagonalizable. A basis for the eigenspace corresponding to 5 is 0, 1, 0 and minus 2, 0, 1. And now we've done all the hard work. To diagonalize A, we take the matrix that has the bases for the eigenspace corresponding to 4, then the bases for the eigenspace corresponding to 5, multiply it by the matrix with the eigenvalues down the diagonal times the inverse of the first matrix we found. And we won't find the inverse here.
Make sure to subscribe for more Coffee and Math with Dr. Weselcouch. Don't text and drive. Bye-bye.